All right, so we are going to wrap up Unit 2, the last presentation of Unit 2, which is going to be an introduction to soil science, the basics of soil science. We'll talk about mainly the different types of soils, uh, how you classify soils, how you use the soil composition pyramid or the chart, and look at the horizons, which is the big point of emphasis here in this unit, or this section rather. So who cares about dirt, right? And that's what most of you probably think. Most people I talk to that are not from an ag background kind of tend to think that, well, we should all care about dirt for multiple reasons. That's some things that we're going to talk about in this presentation. But I'd like for you to think of some things of, why should we care about dirt? So kind of a fun fact, this is not anything you'll have to remember for your test, but it's just interesting to know. So in all, about 38% of the Earth's land surface is used for agricultural purposes. And that's quite a big chunk, almost 40%. If you think about that and as a whole, then a lot of the surface area of the Earth is used for agricultural purposes. So that plays into why is dirt important and why do we care about it? So what is soil made of? Soil is made up of minerals, organic matter, air, and water. Soil composition is influenced by climate, organisms, landforms, parent material, and time. So based in different areas of the world, or for the United States for that matter, you'll have different composition of soil, and that's based off of the history of the area. And we'll look at some of those examples as we move through this course. Soil composition. So soil is a thin layer over most land that is a complex mix of rocks, nutrients, decaying matter, water, air, and billions of organisms. Many, many, many microscopic organisms or microscopic decomposers can be found in the soil. And we'll look at a common food web for soil, and it can be complex, and it is the one we'll look at is complex. But the soil is also an ecosystem. Think of it as an ecosystem. You have many organisms that live there. You have many organisms that contribute to the soil and its ability to um, produce plants to grow, which makes an ecosystem themselves. So the dirt, so to speak, is an ecosystem. So why is it important? It goes back to the original question that we asked. It's a renewable resource. Even though, and think about what a renewable resource is. Over time, it will replenish itself. Now, here's the kicker with soil. This is why it's in slow in parentheses. It takes a long time for the process of weathering to happen. So remember what weathering is. Weathering is the breaking down of rock into smaller rock, into sand, and eventually into soil. Okay, that's a long process. It doesn't happen quickly, naturally. So even though it's a renewable resource, um, it does take a long time for those for dirt to be replenished, so to speak. The next bullet, if you look, it said depends upon the climate, but typically you only get 1 centimeter of new soil formed naturally in 15 years. That's not a lot. Okay, so if we're in an area where soil is not being taken care of, you'll lose a lot more than 1 centimeter a year or in 15 years. So you're losing more than you're replenishing if we don't have proper soil management practices. Soil is the basis of life, okay? Not only for plants, but as you see in the picture, it's an ecosystem for a lot of microorganisms. And the microorganisms is what gives bigger life, macroorganisms, life as well. Soil is a great filter of water. And we talked about the water cycle. We talked about some water does filter into the water table or the underground water system. Soil will filter that out, take away some of the minerals and the chemicals that may not need to be there. Soil is also a great option for water storage in certain climates. And as we've said multiple times already, it is a habitat for a lot of organisms that are important for the circle of life. And yes, we'll use a Lion King reference. So a simplified soil food web, as you can see, it's not very simplified, but you have a lot of um, microorganisms, okay? your bacteria, and then move on up to some protozoa, and then into some roundworms. And we'll talk about these different types of animals when we get into our animals unit. You have multiple different types of insects. Okay, most of these help with the breaking down of organic matter, which will put tons of nutrients, valuable nutrients, into the soil. So soil formation. First way is weathering, as we've already said, and this is physical and chemical breaking of rocks and minerals into smaller pieces. Erosion and deposition is the pickup, transport, and drop off of material from one place to another. We'll talk about erosion more here briefly. And then the last one is decomposition. This is the breakdown of waste, organisms, and organic material into more simple molecules. So these are the three main ways that soil can be formed. So if you look at this picture, okay, this diagram, you'll see if we start at the far right, if you can see my mouse, we've talked about this in a lot of classes, but this is succession. Typically, how new soil is formed, whether it's on brand new land or after a natural event. So you'll have rock, and over time, you'll have mosses and other small plants begin to break down that rock into a little bit looser soil. And then you'll have bigger plants with root systems that will break down that rock more before finally you have large plants like trees, which really start to break down that rock and really turn it into soil. Okay. Decomposition. This is the process that provides most of the nutrients for the soil, which are important for agriculture or for growing anything, just for the overall health of an environment or an ecosystem. These organic nutrients from decomposition are extremely important. These can come from wood or trees that have fallen on the ground and rotting over time. It could come from organisms that have died and they are being decomposed back into the ground. It could come from leaf litter, which we can look at here. We're entering the time of year right now where leaves are going to start falling. Those leaves will eventually decay and rot, and all the nutrients found in those leaves will enter the soil and put nutrients back into the soil, which will be used for next growing season once winter's over. All right, so the big point, soil horizon. So you have O, A, E, B, C, and R. Okay, it's important for you to draw this out in your notes. Get this diagram in your notes somehow. So soil horizons are distinct layers of soil. A cross section of soil horizons is a soil profile. Okay, that's an important vocab term. A is the most critical soil horizon. So if we look at A, this is the topsoil. This is where all that organic nutrients are going to be found, and this is important for growing anything, and how successful uh, you will be or plants will be in growing. If there's not a lot of topsoil, or if it's poor topsoil, then you will not be able to grow things very well. Organic matter is concentrated in O and A horizons, making them the most critical for agriculture, as we just said in the last slide. Now I want to go back. And if you did not have time to draw this or put this diagram or soil profile into your notes, feel free to pause the video now until you can get that in your notes. Label them O, and then also what it is. Give a um, quick little description there underneath each of those horizons, and then you can turn the video back on once you have it in your notes. So is all dirt the same? I think most of you know the answer is going to be no. It's based off different areas of where it's composed at, what makes it up. And so we're going to look at ways that we can classify soil. So soil characteristics. Soil groups are further classified according to properties such as the color of the soil, the structure of the soil, the pH, and the texture. Soil texture is based on particle size. So if we look over here, you see a relative size comparison to different things that make up soil, gravel being the biggest, sand, silt very small, and clay is invisible on this scale. So the texture will be more grainy the bigger or larger the particles are, and more smooth or evenly distributed the smaller they are. So this is going to play into what you're going to do for your soil lab tomorrow. This is a chart which we can look to classify different types of soil based on the percentage composition of three things: the percent of clay, the percent of silt, and the percent of sand there at the bottom. Okay. And again, sand is larger than silt, and silt is larger than clay. So if we're giving a soil profile and it is 50% silt, 50% sand, and 50% clay, then we draw a line from all three moving until they intersect, and we would be in the clay soil profile. Okay, so we'll work with this tomorrow, and we'll work with this many different times throughout the class. Topsoil color is a great and quick indicator of how healthy this soil is. So if the topsoil is dark, loamy, and neutral pH, then that is some of the best topsoils for farming. Dark color often means that there's lots of decayed material, or also known as nutrients, in the soil. So when you're getting ready to plant, say, a garden or anything, if you can look at the topsoil and it is dark like it is in this picture, then it's probably really good soil for you to be planting things in, and anything that is lighter is probably not going to have enough nutrients, or it may be extra dry or extra compacted, which is not going to be well or bode well for plants to grow. All right, so moving into the last little bit of this presentation, some estimates predict that 50 million people could be displaced in the next 10 years due to desertification, a form of soil degradation. And we'll talk about what desertification is. This is basically the drying out of soil because of poor soil management techniques. So erosion is a big problem in agriculture and agricultural practices, especially if common and successful practices as far as management and renewable practices are not used. Some causes of soil erosion, natural causes, is wind and water, and people also kind of expedite this process based off the different type of practices they use in land management techniques. Soil erosion often occurs faster than the soil is formed. We've already talked about that, and which depletes fertile topsoil. So the topsoil is there at the top, okay, that A horizon. Um, it is the first one to erode away. So if you're losing your topsoil to erosion, then you're losing those nutrients that is needed to grow plants. One natural way to stop this is plant plants like crops, trees, and other plants that have strong root systems to hold the topsoil in place. So more than 470 billion acres of the world's croplands suffer from erosion and other forms of soil degradation resulting from human activity. That is a lot, and that's just a fun fact. You don't have to put that in your notes. So some impacts of soil erosion. We already talked about the loss of soil fertility, that topsoil where the nutrients are found. Sediment runoff causes problems in surface water. This is a common source of pollution, especially if chemicals and fertilizers are not used properly and they run off into surface groundwater reservoirs, and that water will become polluted. As it says, it's the number one source of U.S. water pollution. It's renewable only on long-term frames, and we've already talked about that. It takes anywhere from 200 to 1,000 years to replace 1 inch of soil. So just to think, what time of the year do you think most farm fields in the U.S. are vulnerable to erosion? You think about it a little bit. Um, I would venture to say right now. Okay, this time of year, harvest time, once plants are harvested and it begins to get really wet and there's not a lot of living root systems to hold soil in place, right now could be a time where fields are the most susceptible to erosion. Ag land in the U.S. today, soil is eroding 16 times faster than it is created. Sorry about the phone ringing. I'll have to call them back. So, farming practices that reduce erosion Intercropping is different crops mixed together. Crop rotation, crops are alternated. Shelter belts, tall plants block wind. Conservation tillage, soil turnover is reduced, and terracing, the steep slopes turned into steps, which also help prevent erosion. So these are just some different methods that can be used, also based off the land type, to reduce the amount of soil erosion. So tillage versus conservative tillage. So if we look here, this is full-blown tillage here on the left. We're really turning this dirt over. And if the land is not flat, then this dirt being loose is more susceptible to eroding with heavy rains. Here is more of a conservation tillage where we're not fully turning the dirt over, the ground over, and it's not as susceptible to erosion. There's times when full tillage is needed, especially if nutrients need to be added back to the topsoil layer. And then there's times when this type of tillage is acceptable, excuse me, and can be used. And again, you can pause this video and get some advantages and disadvantages of both. It's a good little chart here. Ranching practices. So ranching is the raising and grazing of livestock. Overgrazing causes and worsens many soil problems. Range managers encourage grazing limits and enforce them on publicly owned land. So overgrazing causes plants to die out, which will loosen up soil due to lack of root systems within the soil. So overgrazing of especially large ranch operations is a major problem to the depletion of soil nutrients. So you can look at this flow chart, some things that happen with overgrazing. So one thing, if you have a large ranch operation, you have the compaction of soil, which kind of doesn't allow air and water to flow freely through the soil. It also removes native grasses, which could be used or which are used naturally to hold on to dirt. Decreases, like I said, decreases pores for water and air. Allows for invasive species to outcompete native species because of the altered environment. So if less water, less air is now in the soil, then the native grasses or native plants may not be able to adapt in time. And that could lead to competition for invasive species, which will eventually kill out the native grasses and plants. So this can lead to decreased grass growth and survival, which leads to wind and water erosion of the soil, which leads to ultimately the depletion of the topsoil layer. So a few forestry practices, we're nearing this, we're rounding up. We don't have a whole lot of slides left. I know it's a little bit longer. Forestry practices such as clear cutting can increase erosion. Today, practices that reduce soil erosion, such as selective logging, are increasingly common. We don't see a whole lot anymore of just full hillsides being cut down of timber. It's more selecting of the bigger ones, leaving some to continue to grow, thinning of a forest, not full cutting down of an area of forest. So that helps erosion not happen as fast and also keeps it from happening. Soil pollution. Too much or carelessly timed irrigation can waterlog crops and lead to salination, a buildup of salts in upper soil horizons. Toxic pesticides can remain in the soil for a long time, eventually filtering to groundwater. So these are two common forms of pollution in the soil if proper management techniques are not used. So this is an example of an area where too much water, too much moisture has been put, whether it be naturally or man-made wise, and this will cause for this area to not be able to grow things. Okay, it's almost kind of poison or toxic to new plants or to grasses, and that's why you see the different types of color. It looks real sick. So the last slide, the definition of desertification is a type of land degradation in which a relatively dry land region becomes increasingly arid, typically losing its bodies of water as well as vegetation and wildlife. It is caused by a variety of factors such as climate change and human activities. Causes are overgrazing, deforestation, erosion, salination, soil compaction, and natural climate change. And that is the end of this presentation and also the end of Unit 2. Please be sure you complete the video form that goes with this video. And if you have any questions, let me know. Thank you.